Okay, now we're going to put a lot of these rules and all these shapes and everything we just learned to practice by figuring out exactly where these electrons are in every single element. So we're going to start at the beginning of the periodic table with hydrogen. Now hydrogen, I already filled in for you, has 1 electron. And I know that because when we look at the periodic table, hydrogen here is number 1. So it has 1 electron in it. And remember we said we're going to signify electrons by arrows to show whether they're going clockwise or counterclockwise. Now if you're typing this in, go to your fonts and choose Wingdings 3 as the font, and use the letters lowercase h and lowercase I, and those will be your up and down arrows. That way you don't have to keep drawing these over and over in OneNote. So that's 1 electron, and it's spinning in the clockwise direction. That's it. We're going to go to helium. Now helium has 2 electrons. So we have to draw 2 arrows. That's where this number 2 comes from. He has 2 electrons. 1 up, 1 down. Now the reason I put them right next to each other is because the way I did this chart is this is the 1s sphere right there. I don't want to do arrows. It's probably a bad idea at this point, but that's the 1s. And remember, a sphere can hold 2 electrons as long as they spin in opposite directions. So that's all there is on the first energy level, because the first energy level is right next to the nucleus, and it's very, very small. We don't have any of the other cool shapes going on there. Nitrogen has 7 electrons if you look on the periodic table. So 1, 2. So it fills up that first sphere. 3, 4. Fills up the second sphere. Then it gets into these P shapes. Remember, there are 3 P shapes per energy level. Well, they each get their own room before pairing up for these electrons. So you're going to do all your up arrows first, and then you're down. So I have 1, 2, 3, 4, 5, 6, 7. Okay, because I even drew it up here. 1, 2, 3 P shapes. So each shape gets an electron before they start doubling up and pairing, because they want to repel each other. So that's 7. Neon is our noble gas, and it has 10 electrons. 2 in the first S, 2 in the second S. That brings us up to 7, right? 8, 9, 10. It's completely full. That's why it doesn't want to bond with anything. That's why we're learning this, to know what bonds and what doesn't. Because these outside electrons, these valence electrons, the ones right here in the outside ring, are the ones that are going to determine how well it bonds. Like nitrogen above has 3 empty spots. That's why it'll have a -3 charge when we're crisscrossing down, because it wants 3 more negatives, 3 electrons. To be like the noble gas neon. All right, phosphorus has 15 if we look at our periodic table. So I'm going to put the 10 in that we already know. 10, 11, 12, 13, 14, 15. And last but not least for this table is calcium. Calcium has 20 electrons. I'm going up to 15 at least, seeing as that's going to be the same. 15, 16, 17, 18, 19, 20. Notice what we just did, these arrows are called orbital diagrams, because they're showing exactly what's going on in the orbitals. Okay. From here, we're going to get something called electron configurations. This is what we're really going to be working with a lot, this chapter, the orbital diagrams, electron configurations, or the electron configurations, because they're a summary basically of what we just did. So the electron configuration for hydrogen in the first energy level, so draw big number 1, rotating in a sphere, so lowercase s, we have 1 electron, superscript 1. So the electron configuration for hydrogen is 1s1. For helium, we're still in the first energy level, still rotating in a sphere, but now we have 2 electrons, so it's 1s2. Nitrogen, first energy level, in the sphere, we have 2 electrons. Second energy level, also in the sphere, we have 2 electrons. Second energy level, in the P's, we have 3 electrons. So its electron configuration is 1s2, 2s2, 2p3. Neon, first energy level in the sphere, we have 2. Second energy level in the sphere, we have 2. Second energy level in the P shapes, we have 6. So its electron configuration is 1s2, 2s2, 2p6. Phosphorus, 1s2, 2s2, 2p6. And then we have in the third energy level, in a sphere, we have 2 electrons. And also in the third energy level in the P's, we have 3 electrons. And finally, we've got our calcium, 1s2, 2s2, 2p6, 3s2, 3p6. This time, so you have 6 electrons in there. And then 4s2. And I'm sure you've already noticed that this says 3d. That's not a typo. It should be 3D because these electrons do the lowest energy level first. They're more likely to rotate or orbit in a sphere than in a D shape or a 4 lobe. So it does take less energy. So they will fill the 4s before they fill the 3D. That's why we're not doing any more orbital diagrams past this until we get our hands better grasp on that. The last thing we're going to do here is called drawings. That's exactly what it looks like. All right, so here's hydrogen. I'll do the same color in red. That's the nucleus. Remember, it's tiny compared to the actual space. First energy level is a sphere. I'm just doing a 2-dimensional, more like a Bohr model. That's 1 electron in there. So I'm doing a little dash for a negative for 1s. So that's what it looks like. It's a sphere with 1 electron in it. Helium looks very similar. There's its nucleus. There's the sphere. But you have 2 electrons. And I always draw them on opposite sides because they do repel each other as much as possible. Let's skip phosphorus for a minute. That shouldn't really be there. Nitrogen, there's its nucleus. First energy level is a sphere, 1s2, 2s2, right? Second energy level, another sphere, that's why it's a circle. Now these P's are kind of funky. P's are like figure 8s, right? Now don't draw these lines in the middle, but I want to draw them to show you what's going on here. They're kind of crisscrossing, so that's one of the P's. There's another one of the P's. And of course, here's the third P. Okay, so that's kind of where they get that generic nuclear symbol with all the little, circles going all over the place. It's from these P orbitals because they look cool. But you'll notice the red ones are all one sphere, the blue ones are all one sphere, and the green ones are all one sphere. So for nitrogen, we have 3 electrons, but they have to each go in a different one. I usually fill the top first, so I have 1, 2, 3. Doesn't matter where you put them as long as you have 1 in one of the reds, 1 in one of the blues, and 1 in one of the greens. That way they spread out. Okay? Nitrogen, neon. Do that one in black. 1s2. Second sphere, 2 electrons. 2s2, 2p6. 1, 2, 3. And even if they're not all filled, you want to draw all 6 of these little bumps. You want to draw the entire P shape. So that's neon. Now we're going to go back to phosphorus. I don't know why I was drawing out of order down here. That's your nucleus. 1s2, 2s2, 2p, 1, 2, 3, 4, 5, 6. All right, now we need another sphere. So 3s, 2 electrons on there. You'll notice as we get higher with these principal numbers, these big numbers, these principal quantum numbers, it's getting larger and larger. 3p3. 1, 2, 3p shapes, and only 3 electrons. 2, 3. Notice I drew them even if they're empty. And our last one, and this is why this is the last one. I'm never going to ask you to draw a d orbital. So this is the last one I'm ever going to ask you to do this type of drawing with. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay. So those are orbital diagrams, an introduction to electron configuration, and also the drawings. Okay. And that's about it for now.